We introduced JPA as part of the within a Spring Boot application. We configured the data source so that the JPA could log into our database. We declare the libraries for the MySQL connector to download and the libraries to connect to MySQL. We also downloaded a JPA provider that is provided by Spring Boot, which is based on the Hibernate standard. We also looked at modeling a couple of classes and some relationships. We looked at the user as a plain old Java object with some annotations that converted this Java class into an entity. And that entity could be then stored and retrieved and interacted within a database through a repository, which again is a JPA standard. We saw that the JPA created a table for us. We inserted a couple of data in there, and we were testing it by using the repository to retrieve the data using some of its standard API, such as find all, find by ID, delete, save, and whatnot, to interact with the database through the repository. These are some of the standard API that JPA provides to interact with the database. Find all, find by ID. We also looked at some custom queries that allowed us to configure, go beyond the default API that the repository gives you for retrieving all, find by ID. That we can write our own queries, right, by providing a function, the signature of a function, and then mapping the parameters of that function into a query that could be used to interact with the database. We saw that we looked at a couple of two different syntax for that query. That query could either be a native query that was used verbatim to directly go into the database and do a select or an insert or an update or delete, or instead we can use this JPQL, which is a higher level language that allowed us to interact with the database, but from the point of view of objects. So here in the JPQL syntax here, we are selecting all S instances from objects, so all object S that are of type user, where user is a class, not a table, right? That where the object's instance variable username is equal to some predicate. We pointed out that this syntax is higher level, right? It's not specific to any particular vendor. That this is converted into whatever dialect the database is expecting, right? So this allowed us to stay vendor independent, right? Vendor agnostic, as opposed to if you go down to using native versions, then you become tied to that particular vendor. JPA supports both, right? Whether you want to use JPQL or the low-level native version. We played around with find user by username and by other predicates. We saw how to save data using save. And we pointed out that this save function here is actually can behave as either an insert or as an update. In this case here, because we are creating the user from scratch, then this user certainly does not exist in the database. So this save understands that this must be an insert, right? That this is an object that we created ourselves, that we didn't retrieve from the database, and so this is considered to be an insert. Whereas if we retrieve some instance object from the database using a finder, now this object Bob, this is not an object that we instantiated, right? This is an object that is mapped to some record in the database. So this Bob object here is considered to be we refer to it as a managed object, right? It's not an object that that we created, we instantiated. It was instantiated by the framework, right? And it's tied to some record in the database. So this even though this object uses the same API that we would expect based on the data type user, right? We would expect that the user has all the setters and getters that we defined, right? We defined the set, the get, right, for all the usernames, password, all the fields, we created them, right? And notice that we are indeed using it. We were saying Bob.set first name Robert. You see that? So even though it looks like we're using an object of type user, actually we're not, right? The JPA library, what it does here is that actually Bob is an instance of an object, right? That inherits from user, right? That implements the same exact API, and we are using it as if it were an object of type user, all the setters, all the getters, right? But actually internally, these are our methods that wrap the real methods, right? Meaning that when you call set first name, you're not really calling the user set first name. Instead, you're calling a wrapper object, right, that is intercepting all the communication with the object, right? And to keep track of what is it that you're changing, right? To keep track that, hey, you changed the username, you changed the password. This object is now dirty, right? This object is no longer in synchronization with the record, right? The record says that your username is Alice, right? But here in memory, now you've changed the username to something else. Now the record is no longer in sync with what is in memory, right? And JPA wants to keep track of that the object in memory is now dirty, right? That it needs to update, right? If you retrieve the object Bob and you don't touch it, you don't call any setters, and you do a save, the JPA is just going to ignore you. It says the object was never modified. It's not dirty. It's the same object that I just retrieved. There's no point in doing an update. Okay, so it keeps track of all the modifications that we do to the object, to keep track of what you change. Also, to do some optimizations. If we only updated the username, there's no point in updating everything, right? The update statement will be to only update the username, right, and not touch anything else. Okay. So we refer to it as a managed object, okay, and it behaves just like the Pojo that we created, right? It's meant to behave that way. So this save here is now interpreted as an update as opposed to an insert, right? Because this is a record. This is an object that represents a record in the database. Make sense? Yeah, we also played around with delete. Yes. Yeah, no, we could create it also manually. We can do all the inserts. This means that you've retrieved this Bob here matches a record. Whether it created it or you created it manually, it doesn't matter, right? It retrieved, it ran the query, find user by username, right? It found the record, right? And now you have this instance mapped to that record, irrespective of who created it, either you or JPA. Yep. Yes.
So what if there are two entries of Bob in the database? So what exactly comes in the user Bob?
Yeah. So this find user by username, when we wrote it, here we have find user by username. Presumably, this username is a single object, right? That presumably username is a primary key or some unique identifier. And notice that it's returning user, right? And but we might have written the query wrong, right? And it's not returning just one record; it's returning multiple records. So it would return the first record, right? And it would ignore all the other ones. So we could have written this to be list of users, right? That could have been all the users, between that were whose date of birth is in a particular month or something, right? Or a particular salary. And then you could have written a list of users, and we'd have returned. And even if it was just one, it would be an array of users. Yeah. So we saw saving data, we saw updating, deleting, modeling inheritance. Yeah, so this is where we stopped. So let's take a look at this now.